Hi everyone, my name is Devang, and in this particular video we will be talking about applications of stack. Okay, applications of stack. So basically in the previous videos we saw like how the stack works, how we can implement stack, and all that we saw in the previous video. Now in this video we will see what are the applications of stack. Okay, so the first application of stack is the evaluations of various arithmetic operations. The evaluation of various arithmetic operations. The number second advantage of using stack is the balanced parenthesis check. The balanced parenthesis check. Okay, so what do I mean by the balanced parenthesis check? Let's understand this. Every expression would be having some brackets, such as, let's say I want to say that 2 plus 3 multiplied by 4. Now to check in this expression like whether the parentheses are balanced or not, we use the stack. This is the purely stack based problem. Okay, the compiler uses stack for checking the syntax. Like if you read the compiler, you will know that the compiler checks the syntax phase. Like in the syntax phase of the compilation, it checks like if the code written is in the compiles with the syntax of the language. So that is also an application of stack. The third application of stack is recursion. Actually the recursion works like a stack. Like in the recursion, the stack is filled. And then the states are being popped out, and the flow is maintained. The fourth is the strings one. In the many string problems we use stack only. Okay, so now we have discussed about this. In this video we will discuss this point: evaluation of various arithmetic operation, that is infix, postfix and prefix operations. We will discuss about these. Okay, and in this video also we will discuss about the STL implementation of stack, that is standard template library. Okay, so before proceeding any further, I want to make sure that you know about Newton School. So Newton School is a website from where you can learn anything for free, and you have to pay zero fee until you are placed. Okay, and also this is like they have extra advanced teachers for you to get a hint like what is doing in the placement, and what is going on in the technical industry, what projects you need, what should be in your resume. All things will be taught to you. They have teachers which are from IIT and NIT. They have a tie-up with among 300 plus companies, so you get an assured package of 5 lakh to 40 lakh CTC. The companies vary, such as Unacademy, Snapdeal and so on. So make sure that you go and check out their website. Now the Newton School has launched an initiative which is known as Launchpad. This is like different from this. Launchpad is the site or the initiative of Newton School to make India developer power of the world. In this section you will be getting all the courses for free. There is no cost at all. All the courses for free. Like you will be interested in Android development, web development or machine learning, you will get all those courses for free. And if you complete like this particular course from that only, you will get a certificate of completion, and also you will get a doubt support, which is very important. As I already said, that 5% is theory and 95% the practice in DSA. So the doubt support is very important, which you get under the Launchpad section. So make sure that you go and check out the website. Okay, so now first of all let's discuss about STL implementation of stack. Okay, now what happens in STL? In STL we have making various libraries so that we can use such data structure with no external cost. Okay, so you have to just write this code like hash include input output string and using namespace standard. Let me just okay. Then we can say hash include stack, Actually, this is the header file which contains the stack. This is the header file that contains the stack. Okay, then we can say that using namespace standard, and then we can write our main function int main. Okay, so here our code can come. What kind of a code? Now remember, in every STL which you are going to encounter, so in every STL which you are going to encounter, the format or the syntax of the particular data structure is always the name of the data structure. It is a template. Remember this term, it is a template. Okay, so the name of the data structure with these arrow brackets and the name which you want to give. Here should be the data type. This kind of a thing you should remember for all. For example, if I want to initialize vector, what will I do? Vector int s. This is the code for vector. Now similarly, I will use the same kind of a thing for stack. Stack int s. And here I go. I got a stack of size 0, empty stack. By writing this statement, I am given an empty stack. Now I want to push element into the stack, so I can do s dot push 10, s dot push 20, s dot push 30. I can do this kind of a thing. Okay, and also if I want to pop the thing, so s dot pop will be my thing. Okay, I have a function s dot empty. I have a function s dot full. I have a function s dot top. Let us do a thing. Let us just print the okay, so while s dot empty equal to false, so cout s dot top and s dot pop. So we can do this kind of a thing. This will, traverse the stack. This is supposed to traverse the stack. Okay, let me write over here, traverse the stack. Okay, so I hope that you got a hint of what we will do in the next part of the video. So this is the implementation of STL, like how we can just use this. So you can use this part of the thing in various questions. Okay, so rather than writing your whole class and all that, you can use also this. This is an internal class. You can say this is an internal class. Okay, so now let's proceed further and see what are the arithmetic operations that I was talking about. Before that, you should know that all the stack functions such as push, pop, top, empty, all that, they are doing their job in big O of one-time complexity. Okay, so now let's proceed further and talk about what are the applications of stack. As I said that various arithmetic operations can be done with the help of stacks. Okay, now we have basically three types of arithmetic expression. One is infix, another one is postfix, and third one is prefix. Basically infix means, okay, just a minute, yeah. So to identify this, like how do you can identify which operation is which one? Always see the first two letters, in, post, pre. In means between, post means after, and pre means before. Okay, whenever you heard the term infix, always your mind should strike like the operator is placed between the two operands. The operator is placed between the two operands. What kind of operands? A plus B, X plus Y, 2 plus 3. These all are the examples of infix notation. Then we have postfix notation. So in postfix notation, the operator is placed in first place, like in the last, sorry, I just in last, yeah, So like xy plus ab plus 2 3 plus, all of these have same meaning. All of these have same meaning. Okay. Prefix means before. It means that the operator is placed in beginning, like plus xy plus ab plus 2 3. Again, all these terms have the same meaning, but these are the various ways to express like what we will how we can evaluate the arithmetic expressions. So basically, in the journal, journal structure, like journal, when we are doing some problems, we use this kind of a expression. But the drawback of this kind of expression is that it requires a lot of parentheses. And you have to take care of some of the rules, such as division, multiplication, addition, and all that. You have to take care of all the rules, such as if I write the statement 2 plus 3 into 5, if I put bracket over here, it means 2 plus 15, which is equivalent to 17. If I write 2 plus 3 into 5 and I put bracket here, it would mean 5 into 5, which is equivalent to 25. So the one bracket changes all the situation. So in this, parentheses are so important. But in the computer, the calculations are made with the help of stack. So it has to remove the parentheses first. So to increase the efficiency and to get rid of this parenthesis stuff and all that, we use postfix expression and prefix expression. Now these expressions are very helpful for the computer, because it does not have to evaluate any kind of a parenthesis structure and all that. It just have to look for precedence and associativity. We will talk about these two terms in this part of the video only, but just try to understand this kind of things are better and very helpful for the computer. Okay, now let's discuss the two terms that I said, which is precedence and associativity. Okay, so precedence means, okay, just let me change the color. Yeah, so precedence means the order in which the operators are evaluated. Okay, and associativity is how, in which manner we are going to evaluate if two operations have same precedence. It might be confusing here, but let me explain you more. Let's take the example of this question: 20 plus 30 into 2, right? Now how you will evaluate this expression? You do not have any kind of a brackets. You do not have any kind of brackets. How you can evaluate this expression? So first of all, let us see the table. We have the table like this, and just remember this kind of stuff. In this way, the precedence increases. Okay, so the first precedence, like this has the highest precedence, lowest, highest, lower, lowest, and this is the associativity order. Now here you can see that first we have encountered plus, but we have a higher associativity, higher precedence, which is of multiplication. So firstly, let's evaluate this. It will become 20 plus 60. Now we have plus, and the answer would be 80. Now let's consider another scenario. We have 20 plus 30 minus 2. Now operator plus and minus have same precedence. They have the same precedence as we have seen here. Now what we can do? We can simply do L to R. L to R means we have to consider associativity. So remember this point. Associativity is considered when the two operators have the same precedence. same precedence, then only the associativity is considered. Now first of all 20 plus 30 is 50 minus 2, which is equals to 48 answer, because we have to evaluate the expression from L left to right. R to L means we have to evaluate the expression from right to L, right to left. Here R means right, let me write over here, R means right and L means left. Okay, so I hope that you are getting clearer about the things. And this is the expression for power, this is the expression for power. Okay, now let's do a short question. We are given x into y plus z. This is our infix notation. We have to convert it to prefix notation, or you can say that postfix notation. So for postfix, the step 1 should be apply the parenthesis, like write the parenthesis for the given expression. X into y plus z, draw the table, R L L L R R. I remember like this. Okay, so you can also remember like this is a synchronium, R L L L R R. Simple. So first of all, this one, then x into y plus plus z. So the first step, which is to parenthesize the given expression, we have done that. The second step is to convert the given expression in the asked form with the help of the rules. Like first of all inner, then outer. We have to follow this order. First of all always open the inner, then the outer. Just convert the expression that you are given in accordance to what you have asked, such as prefix or postfix, and always converts from the inner, then go to the outer part. As in here we will have x by postfix into plus z, so it becomes x y into z plus. How this comes? Just a minute. Yeah, think about x y into is equals to a, so this becomes a plus z, it would become az plus. Now fill the value again, so x y into z plus. So this is how we can evaluate. Now let's evaluate the same expression. Let me just rub this. Now let's evaluate the same expression for prefix also. So first step, draw the table. This is power, this is multiply, this is divide, this is plus, this is minus, R L L L R R. Okay. First step is to parenthesize the given expression. So x into y plus z. Second step is to convert in accordance to the given. So it would become into xy plus z. Say that into xy is equals to a. So a plus z, it would become plus z plus az. It would become plus multiply x y z. So this is our answer. So see how simple is that. So in this video we have talked about what are infix expression, what are postfix, what are prefix, what are the applications of stack, and how you can use stack for various operations. Now in the next video we will see the algorithms for this evaluations of prefix and postfix operations. Till that, if you have any doubt, make sure to comment it out, and make sure that you also check out the launchpad section. Okay, thank you.